Hello students, today's agenda is to check homework. We'll learn about side, 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 and side angle side, congruency, and you will be able to work on 9.7. Today, students will be able to identify congruent pairs by side, 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 and side angle side. And you will also be able to write congruency statements for triangles. So what does the word congruent means? Congruent means that it has the same measurement for sides and for angles. So it says, now in order to prove that two figures are congruent, you check the angles and you check the sides. So in here, we can say that DC, so line segment DC is congruent to line segment GH. The symbol for congruent is like two lines and a wiggly line on top. Also, because of the double marking, by putting two marks, that means that those two sides with the double mark are congruent. So we are going to say that FG is congruent to, since I started at the bottom, I'm going to say that it's going to be AD. We also know that AB is congruent to, since I started in here, it's going to be FE. Okay, and finally, we know that BC is congruent to side, since I started in the corner with two markings, then I'm going to start with the corner with two markings in here, so EH. And so those are the four pairs of congruent sides, but we also know that angle A is congruent to its corresponding angle, which is angle F. Angle D is congruent to angle G. And how do we know? Basically, what's happening is that this has kind of like a rotation and then reflection. So you can check that these are these two angles, right? And this is the one in the bottom, so that's why it's F. This is this angle up here. It's the G because it has the same shape. Okay, so angle B that has the double marking is congruent to angle E. And finally, angle C is congruent to angle H because both have only one marking. Okay, so for sides, you either have one mark, two marks, three marks, four marks, etc. Okay, and that means that they are congruent. They're the same measurement. By having the same number of little strokes or strikes, that means that that's the same measurement. For angles, you use a little arc or double arc, or sometimes even three of them. Okay, and that's in the angle. Those are the markings that they use for congruent angles. Okay, so in triangles there are shortcuts that we need. Like in here, when there are other types of polygons, you have to have every single angle and every single side measured to know that they are congruent. But in triangles, you can just have three parts of them and then you'll figure out that they are congruent. And what does that mean? Well, when you have the SSS postulate, meaning side, side, side postulate, which says that if two triangles have 3 pairs of congruent sides, then the triangles are congruent. Basically, what it means is that as long as you know that all the sides are congruent, automatically the angles are going to be congruent as well. Okay, they're going to be exactly the same measurement, even if you don't have the markings for those. So it's kind of like a shortcut saying that if you have BA, whoops, side BA is congruent to side ED, and you also know that AC is congruent to DF. Notice how I'm using the same order. If I'm going AC, then I have to do the same. And then BC is congruent to EF. Then it says therefore, so I know that these are congruent. Therefore, triangle ABC is congruent to triangle DEF. And the reason, we're going to say by side, side, side postulate. Okay? Now, this other example, we can say that AD is congruent to, since I started over here and brought it over here, I'm going to start CD. And it's because of the markings, right? All of these are because of the markings. That's the reason. We also know that AB is congruent to, since I started in here, I have to use the same order, so CB. And I also know that DB is congruent to itself. So it's the same side being used for both triangles. It's used for that triangle and it's used for the bottom triangle. And again, we can say therefore, triangle ABD is congruent to triangle ABD, so CBD. And again, by the side, side, side. Okay, the reason for which this is congruent to itself is because of the reflexive property. Okay, let's do some more examples. Which of the following are congruent? So now they're giving you four different triangles with different markings, and you have to check which ones have the markings that match, basically. In here we have one mark, 2 marks, 3 marks, so we need to look for another that has the same. So in here we have 1, 2, and 3. In here we have 1, 3, 4, and then in here we have 3, 4, 5. So basically the ones that are congruent are these two. So again, we have to match the sides, and so it's AB is congruent to, AB has 1 stroke, and I'm moving from the vertex that has 3, so I'm not going to say FE, but rather moving away from the one with 3 strokes is EF. And then BC is congruent to, okay, again, now I went from the 1, 2, so 1, 2, that means FD. And finally, CA is congruent to DE. Therefore, triangle ABC is congruent to triangle EFD. And it's by side, side, side postulate. Okay, and again, these are not congruent because that means that this has the same measurement as this with 4 markings, but the 3 with the 5 don't match. Okay, oh, I mean 3 with 3, but the 5 with 1 doesn't match. Okay, another example. Which of the following are congruent? So by the measurements, we have 3, 4, 5, 3, 5, 5.8. Those don't match. We have 1, 3, 4, 5. Okay, those match. And then 4, 5, 6.4. So the ones that match are ABC with HGI. Okay, and again, I'm just gonna put instead of giving you each side, I'm just gonna say that triangle ABC is congruent to triangle HGI, and it's by the side, side, side postulate. Remember that if you need some more time, you can definitely pause the video. So in this example, it says, which of the following are congruent? And so we have several things going on in here. First of all, we have 4 triangles, and some of those are sharing sides. For example, these 2 are sharing this side, these 2 are sharing this side, and these 2 triangles are sharing this side. Okay, so as you can see, for this triangle you have 1 marking, 1 marking, 2 markings. For this triangle is 1 marking, 1 marking, 2 markings. For this one is 1 marking, 1 marking, 2 markings. And for this one is 1 marking, 1 marking, 2 markings. So basically all of them are congruent to each other, and you can just basically create several pairs of congruent triangles. I'm just going to give you 2 because this is going to come back in the other example. So I'm just going to say that triangle ABD is congruent to, I'll just use this one, triangle, and in reality you don't know which 2 correspond to A, which of the 2 corresponds to A and which one corresponds to B, because they are isosceles triangles. So as far as you may know, this could be flipped, or maybe it could be simply translated. So it doesn't matter which one you write first. C, D, E. I'm going to put C, D, E. And it's by side, side, side. Okay. Again, you can create other ones. I think I'm just going to leave it at that. But definitely all of them are matching. One thing you should not, for this triangle, for example, you should not match A with either C or D for this triangle. Okay, you just need to make sure that the vertex of the pointy side aligns with the pointy side of, pointy angle of the other triangle. That's the only thing. Okay, before we move to the next postulate, I want you to know and some of you might already know this, that when you have two intersecting lines, they form vertical angles, and vertical angles are opposite of each other. So in here, for example, this is a pair of vertical angles and they are congruent. We also have on the opposite, this is another pair of vertical angles and they are also congruent to each other. Okay, somebody said, oh, it's like when you open scissors and the opposite angles are congruent. Okay, if that helps, you might want to use that as a reminder. So now we're going to learn about the side angle side postulate. And it says that if two triangles have two pairs of congruent sides and an included, sorry about that, and an included angle, then the triangles are congruent. Okay, so these two sides are congruent to, basically switch to these two sides, and the angle in the middle of the two sides, or formed by the two sides, is congruent to the other angle in the middle of those two sides, or formed by those two sides, then that means that the two triangles are congruent. Okay, so basically by having side angle side, then I know that this angle is congruent to this angle is congruent to this angle, and this third side is congruent to this third side. That's what it means. But the shortcut is side angle side. Okay, so in here, let's start doing, we can say that side AC is congruent to side AC. So I went from pointy to right, so with one marking from pointy to the right angle. We also know, now I'm gonna go with the two markings. I'm gonna go with the angle first. And this angle, you can name it with just the vertex, angle C, or you can name it with 3 letters. I'm just gonna write it with 3 letters so that you can get used to it. So angle A, C, B. Another thing that you have to remember is that the vertex that's forming the angle is always in the middle. Is congruent to angle. Since I start over here where the side has one marking, I'm going to start over here with R, P, Q. Okay, so this is the angle. It's talking about this angle right here formed by these two lines. Okay, and we also know that CB is congruent to PQ. Why CB and PQ? Because both of those have two markings. So those markings tell me that these two sides are congruent. Therefore, these little dots, sorry, I forgot to tell you before, means therefore triangle ACB is congruent to triangle RPQ. And this is by side, angle, side. Okay, side, angle, side. So take a minute to copy that, pause the video, and that way you have time. Okay, remember I told you we were coming back to this figure, and the reason is basically because even though they don't tell us more information than all the sides being congruent, if you see here, these two lines intersect so that they form two vertical angles. So those are congruent. And so we can say that these two triangles are congruent by the side, because they have two markings. I mean, one marking, and two markings. One marking, and two markings. But then we can also say that they can be by side, angle, side, because they have two sides that are congruent to two sides, and the angle in the middle as well. So let's create a statement here. So AD is congruent to ED. Angle, and here we cannot say angle D only, because this is angle D, this is angle D, this is angle D, and this is angle D. So we have to use three letters. So angle ADB is congruent to angle EDF. EDF. And we also know that BD is congruent to side FD. Okay, so now we have one side, one angle in the middle, and another side, and we can say, therefore, triangle ADB is congruent to triangle EDF. And this is by side, angle, side. And again, we know that the reason is because there are vertical angles. The reason for this one is because they have the markings. They also call it given. Okay, and this also it's because of the markings. Okay, so take a minute, pause the video. Okay, another example. Are the following congruent? So I'm not going to give you the whole list. I'm just going to show you, and you can write it if you wish. But we are going to say AC is congruent to EC. Notice how I go in that direction. So maybe I want to write it so that you have that in your notes. So AC is congruent to EC. And the reason for which I put that little arrow is just to remind myself, oh, I'm going in this direction, so it looks like I need to go from here to here, because this looks like they correspond, okay? Then another thing that I have is DC. So I'm gonna go, if I came this way, then I'm gonna come here like this. So DC is congruent to BC. Okay, and another information that I have, or I don't have, but I know because I remember that vertical angles are congruent, is that, and since they're in the middle, I'm just gonna put it in here, squish it in here. Angle, since I used ACB, ACB, then in the other one is, notice how I started with the orange and then green, so I'm going to start with the orange in here. Angle ECD. Okay, now I have, this is a side, angle, side, so this automatically tells me that triangle ACB is congruent to triangle ECD by the side, angle, side. Okay, side, angle, side postulate. Again, take a minute to note this down. Are the following congruent? Well, in here, I don't have very much information. I only know that these are vertical angles and that they are congruent, and this angle is congruent to this one, but in reality, I don't have much more. I have this side being congruent to this same side if we're talking about these two. Okay, so I have one side and I have these angles, but in reality I don't have enough information. I don't know if other sides are congruent. They might be a little bit different, even though they look similar. Remember that it might be different by 1 millimeter, and that's why we can see that difference, or even a shorter amount. So they need to give us the information that they are congruent by giving us markings, okay? Otherwise we cannot assume. So we only have side EC is congruent to side EC, and we don't even know if those are congruent. We only know of opposites, I mean vertical angles. So no, not enough information. Okay. Okay, are the following congruent? So in here, let's see, we have these markings. So I know that AB is congruent to, now I start AB to the lonely, from the one that is busy with the vertex that is lonely, nothing in here. So I'm going to start here by D, because these have markings. Then I start with the ones with markings here and go towards the lonely, no markings in here. So AB, A, oh, I'm sorry, A with all that to B, and then D with all that to C with nothing. We also know that angle CDA, so angle CDA is congruent to angle, since I started with C that has no marking, I'm going to start with B, which has no marking. I went to D that has this double angle, so I go to A, which has the double angle, and then finally to D, which is D for that triangle. It's the one that is very pointy, which is similar to A, which is that pointy for this other one. Okay, so we know that as well. And finally, we also know that this line is the same for both. So we're gonna say for this triangle first, it's gonna be side AD is congruent to, notice how I go from, for this, the one that has the angle, to D that has the pointy. So for this one, I'm gonna go the one that has the angle, meaning letter D, to the pointy, which is A. Okay, notice how in here it got switched because these figures are kind of like rotated. They are rotated instead of flipped. Okay. And so we can say, therefore, triangle CDA is congruent to triangle BAD, and the reason is side, angle, side. Okay, I have a note in here, but it's actually backwards. Note that AD is congruent to DA, or AD to DA. Doesn't, okay, not AD to AD. Okay, so this is side, 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 and side, angle, side, and you are now able to do 9.7.